Computational thinking and its application are the key processes in getting computers to perform a task for the user. Users who can successfully apply computational thinking will be able to consider and understand the steps required to get a computer or electronic device to solve a problem or complete a required function. The Barefoot taxonomy divides the concept of computational thinking into two different areas: the concepts, which describe the complex nature of how ideas may be processed, and the approaches. This describes how the sometimes complicated concepts can be managed and transferred into an activity. Within a primary school, the activities will, of course, need to be tailored to the task at hand, yet by keeping computational thinking in mind throughout, children begin to make links between the problems they face and the way in which ICT can help them to solve them. Other definitions of computational thinking include Wing et al. In 2010, Selby and Woolard in 2014, and Brennan and Resnick 2012. While some of these definitions vary in their explanation, most seem to agree that computational thinking is a process that requires an understanding of algorithms. These are a list of unambiguous instructions that can be followed in order to complete a particular task. While they may initially seem like an imposing concept to teach to young children, the fact is that algorithms are simply a case of pattern recognition. Once the pattern has been identified, the next step is to manipulate it in order to change the input, process, or output of the pattern. In reference to teaching, this can be broken down into a mathematical equation throughout the use of a function machine activity. For instance, if the input was 2, the function, or process, was multiplied by 2, then the outcome would be 4. If the function area is hidden from the user, then they have to analyse the input and output and make their judgments about what the function is likely to be based on their findings. Investigations such as this can be used to encourage logical inquiry, as well as providing cross-curricular links and developing algebraic thinking. The process of breaking down larger challenges into more manageable tasks is referred to as decomposition. Being able to reduce a process to its core components can be helpful when applying computational thinking in the classroom, as it helps to make a larger task less imposing and also develops an understanding of the key concepts that are behind complex actions. The national curriculum promotes the use of algorithmic thinking alongside logical reasoning, and goes on to mention the act of detecting and correcting errors within them. Once children are able to identify the function of an algorithm and its purpose, they should then look to progress into the process of identifying issues within the algorithm. This identification process, alongside the act of fixing the issue, is sometimes known as debugging. Using the language of computational thinking can often assist in creating cognitive links with the subject matter, as well as providing children with a more varied vocabulary in order to express their ideas. It is important to remember that the act of computational thinking does not necessarily require the use of a computer, and as such does not always require the class teacher to have a high level of computational literacy. It is, however, important to understand the key concept of computational thinking, as this is what will allow children to understand the way in which computers can work for them. The importance of computational thinking was reiterated in the British Royal Society document Shut Down and Restart in 2012. They emphasised the requirement for children to be digitally literate by the time they finish compulsory education, and also went on to explain how computational thinking can help to understand the way in which information can operate within a system. During my own block school experience, I was able to observe a number of ICT sessions within the school's computer suite. However, I found the lessons were often heavily focused with the output produced by children, rather than identifying the process was taking place. This result-driven concept appears to be fairly typical of Key Stage 2 class, particularly with time restraints placed on them by the ever-looming presence of summative assessments. Yet time needn't be such a restricting factor. If taught alongside the national curriculum, links can be made to the process of computational thinking and, as mentioned earlier, be applied to a wide variety of subjects. This means that time allocated for computing isn't necessarily the only time that computational thinking can be employed within the classroom. However, not everyone agrees with the validity of this argument. Taubamani and Ben-Ari in 2012 found that only some of the objectives were addressed in the classroom activities, that the activities do not engage the students' prior knowledge, and that most of the activities are not explicitly linked to central concepts in computer science. This seems to imply a misunderstanding of what the core concept of computational thinking is, and not creating the necessary association with computing. So it seems to be that while you can take part in computational thinking without using a computer, the computational thinking process should always be brought back to its use within computer science. By establishing this cognitive link, children are more likely to apply their thought process when using ICT. This is something that I will endeavour to do throughout my own teaching career in order to ensure my students are able to become as proficient as possible within the use of computers and information technology.